Okay, straight on to the next case, slide 16. Sorry, slide 17. Now assume a balanced growth path on which x is constant. So we're assuming that this, you might not have worked this out for yourselves, but we are being told that there exists a balanced growth path on which x is constant. Okay, so if x is constant and we have balanced growth, this is going up, yeah? This balanced growth, this must stay the same. So this must be going up, which means this must be going up too, yeah? So now that means extraction has grown a lot since the primitive economy, and we're actually increasing the depth at a significant rate, driving up the cost of extraction, driving up the resource price. So how is that going to look mathematically? So, where should we start? I guess we start here, don't we? So we've got that x dot is naught. Okay? Or x dot over x is naught, perhaps. But we know from this that x dot over x is, what are the exponents here? 1, 1, minus 1. So it's ax dot over ax, which is g, plus lx dot over lx, which is 0 on balanced growth, lx won't change, minus ad dot over ad, because the exponent here is minus 1, isn't it? So it's g minus ad dot over ad equals naught. So we must have that ad dot over ad equals g. But we know this, so we know that d dot equals x over phi equals g. So x must be phi g. There's a specific value of x which gives us this property of balanced growth. Okay, and it seems like I got it wrong because I'm looking at my crib sheet. It says g over phi. Or maybe the crib sheet is wrong. I think the crib sheet's wrong, isn't it? Let me see. ad dot over ad is g. Which is d, so d dot is g, which is x over phi. Yeah, x should be phi g. I need to change that. Sorry. Okay. So what else can we say? We can easily work out y dot over y. Ay, it's going to be 1 minus alpha times the growth rate of this, which is g, plus alpha times x dot over x, which is 0. So it's going to be 1 minus alpha g, isn't it? Y dot over y is 1 minus alpha g. A bit lower because we're not expanding extraction anymore, so there's a little bit of a penalty. But we always have, given this Cobb-Douglas, we always have wxx equals alpha y. Yep. X takes the share alpha. So x is constant, which means that wx dot over wx must be equal to y dot over y. So the resource price will track growth. So instead of this, the balanced growth path, we should switch it. WR R Y. And actually the y should be a little bit flatter, shouldn't it? Because of this growth penalty. So we can wave our hands around a bit and predict that if we solve the full model over time on a log scale, y would look like this. Oops, too steep. WR would look like this, and R should look like this. Yeah. So this model can explain the current data, and it predicts a smooth transition to this. But here resources are still infinite. They're inhomogeneous, but they're still infinite. What if there's a bottom to this tube? Okay, what if you can have exhaustion? Then we need to move on to the third phase when we start getting close to the bottom. Okay, what happens then? And that is the next slide, 19. But I'm kind of exhausted. I'm going to pause the video. Oh God, I've got to get to work. I've got a meeting. I'm going to pause the video, get myself a cup of tea, finish this off, then get to work. Okay, no cup of tea, no time. But I had a swig of water anyway, and onwards. Slide 19. Now assume a hoteling economy in which the resource is running out. Characterize the path. So now we're saying, actually, we are super close to the bottom. We are scraping the barrel. Okay? What can we say now? How are things going to look? Prices, quantities, and so on. This is so cool. Well, I would think that. It was my paper. I was so pleased with this. Okay. What is going to happen as we start to scrape the barrel? Well, if we're already down here, we can't go deeper than this. What can we say about D? It's going to approach naught, right? And we're keeping things simple here, so I'm not going to talk about tending towards 0 or infinity or whatever. Let's just say, okay, we're super close. Let's just say d dot over d is naught. Okay. Or, yeah, d dot is naught. To then be able to say that ad dot over ad is naught. By the way, x is, yeah, now we don't want it to be x to be literally naught, but x is super close to naught. We can't let x go all the way to naught, because then the whole thing breaks down. We've literally run out. That's not going to happen in this. It's getting so close that we can treat d as constant. That's the point. ad dot over ad then we can treat as naught, ad is constant. So then, what is x dot if ad is constant? Right, okay, yeah. No, we can't, we don't want to go that way. Because if we're still thinking balanced growth, then if AD is constant, we're going to have increasing x, right? If Lx is constant. So clearly that is a contradiction. We can't any longer have balanced growth when we're getting down here. And of course, this makes sense. I'm not sure if I made that clear, but growth is also balanced in the primitive economy. And then we move to a new sort of balance point in the balanced growth economy, by the way. But here there is no balanced growth. Because D is constant. AD is constant. Wages, AX is going up at G, but wages are also going to go up at G, or more or less G. So the unit costs of extraction are going to stay the same. Okay. And in given competitive markets, that means that you would expect the price to stay the same. But if the price stays the same, then given growth in A, Y, more and more resources are going to get sucked in. Again, we've got a contradiction. What is going on? Extraction costs stay the same, right? Because depth is constant, this is constant, this is growing, but the wage is growing. So the two cancel. Extraction costs for X stay the same, but the price of X doesn't. The price of X becomes dominated by the scarcity rent. The closer we get to the bottom of the barrel here, the more negligible the extraction costs become, and the scarcity rent dominates completely, okay, in the limit of very little resource left. The scarcity rent dominates. What's the scarcity rent? We're now in the territory of the Hotelling model, yeah, which we had in this corner before. That the resource price in the limit of zero extraction costs, but a limited resource, the resource price grows at the pure rate of time preference. And the quantity declines. Oh, what was the result now? It's, oh, I can't remember the exact result. Have I got it here? No. I could work it out. I mean, yeah, we could work it out from this. Because Wxx is alpha y. So Wx dot over Wx plus x dot over x is y dot over y. Oh, sorry, I've changed from x's to r's. Yeah, this should be x's. But this is rho. So x dot over x is equal to y dot over y minus rho, isn't it? Okay. And rho is bigger than the growth rate of productivity, and y dot over y is a bit less than the growth rate of productivity, because we got this penalty from decreasing resource use. So if we put these together, y is gradually turning down a bit, but it will still keep growing. R starts tracking y, passes through the level phase, and will then decline. Oh, I should have x. R and x are the same here, yeah, sorry. Let's call it R to be the same as all the previous figures. And WR, here it's flat, here it's growing at the same rate as Y, and then as this declines it's growing at rho, yeah. So that is W. So, if the real world looked exactly like this, and if markets were perfect, this is what we would see. Okay. And when you look at Kiruna and loads of other mining operations, coal mines, etc., it makes total sense that we're still back here. Yeah, we're still scratching the surface. we can talk more about that in discussion in class. Okay, and you can actually, I've moved on to slide 21, you can actually, more in the full version of this model, you can parameterize it and make predictions about like what's going to happen to copper prices over time, what's going to happen to oil prices, and so on. And generally you can say, based the parameterizations I did for the paper, like with copper, it's like, okay, we're going to be turning here maybe in 100, 150 years time or something, I think it was. For oil, perhaps a bit sooner. Other things being equal based on the information we have. Then with oil, of course, we need to think about climate, and hopefully we'll turn much sooner. Okay, I'm going to stop this video here and then start a new one on rounding off about the DHSS and linking in to the next topics when we get right into the heart of the course. But I got a dash now, so that will be tomorrow, I guess. See you soon.